We currently reveal that the Earth's crust, the rocky part of the Earth, is composed of several large rigid plates. These plates are being created at some edges and being destroyed at others. They are also moving across years. This theory is called plate tectonics. It was first put forth in 1963 by a Canadian geophysicist by the name of Tuju Wilson. Tuju Wilson was instrumental in advancing in the theory of plate tectonics. He suggested that the Hawaiian and other volcanic island chains might have formed as a result of the movement of a plate over a motionless hotspot in the Earth's mantle. Hundreds of studies have proved that Wilson was right. However, in the early 1960s, his idea was considered so radical that his hotspot manuscript was initially rejected by all the major international scientific journals. Basically, plates are areas of the Earth's crust that move as a unit. At the present time, there are 8 large plates, as well as a similar number of smaller plates. According to the theory of plate tectonics, a plate has 3 kinds of boundaries with other plates: oceanic ridges, oceanic trenches, and storm-formed faults. Most of the world's earthquakes and volcanoes occur at plate boundaries. This is what you'd expect. Plate boundaries where a great deal of friction and stress occur. And the plate bound and catching one is a rock and forest up from the mantle in the molten form as lava at ridges. Another is that rock is melted the forest back into the mantle at trenches. This process is either swallowed or falls back into the earth's mantle is called subduction. During subduction, as the plate dives into the depths, we think part of it to find its first sign into the form of volcanoes. The theory of plate tectonics and its discovery of shear spreading had confounded the theory of continental drift. Shear spreading was discovered in the North Atlantic and soon afterward in all other oceans. What we found is that in the areas around the oceanic ridges, the deep shear is formed by rising lava, which then spreads out sideways in both directions. So does the spreading of the ocean floor mean that the surface of the Earth is increasing? No, not in the least. Shear spreading doesn't cause an increase in just the surface. And why not? Because the lava that rises and spreads from the oceanic ridges sinks again elsewhere in the subduction zone, which are nearly identical with the ocean trenches. Subduction zones are areas of frequent earthquakes and are usually associated with the rows of volcanic islands that accompany the oceanic trenches. Subduction is currently happening beneath islands arcs like Japan. Subduction is also taking place on the Pacific northwest coast of North America, beyond the end of the Sun-Earth Hole. This is where the solids of Saltobia disappeared beneath the North American plate in the recent geological time, leaving the volcanoes of Cascade Range as evidence of its past existence. Okay.